Hello guys, welcome to your Python programming tutorial videos. In this video, we are going to be looking at Python Bitwise operator. Now, Python Bitwise operator is something you hardly use in your Python career, except you're writing very low-level routines. Maybe you're writing applications which deal maybe with sound or high-level graphics, and you're trying to make them as efficient as possible, and you want to deal with the binary or the bits, maybe some kind of an image processing application, which will really be difficult because Python already have a lot of models which are dedicated for that, which you can just import and use. So you not really, need to write that from scratch, except you're writing maybe for a chip or some hardware, some IoT system. Now, we'll be looking at that in this video so you can understand it. If you reach, maybe if you find yourself in a situation where you will need to do that. Now, let's look at the bitwise operator work on the bits 1 and 0 of a number and perform bit by bit operation. Now, each number have a binary representation, that's 1 and 0. 35 has a binary representation. In fact, the basic of all data in programming or in computer is 1 and 0s, which is the electric voltage 5 and or a high voltage and a low voltage. That's how data is being transmitted via the wire. So now let's not worry about that, but let's look at how we can deal with those bits in our program. Now, bits, to convert a number to a bit, you can use the bin built-in function. Now, if you say bin 200, it's going to show you the bits, that's the 1 and 0 equivalent of 200. As you can see, here is it. It adds an OB, but you can easily remove it because this is a string. You can use the slice operator to remove the first two, or the splice operator to remove the first two digits, but you will see me doing that later on. Now, we have A, B, C, D. These are the binary equivalent of A, B, C, and D. Now, as you can see, some can be very long. Now, let's see. Now, if we have a bin, let's say to show you that the bin function returns a string, I use type E. As you can see, type E returns string, and now I can use the slice operator to move from the second digit 0, 1 to the second index to the n. So I use 2 and I omit the n, which means n. Now, as you can see, I omit the second parameter here, which means n. We have studied this in details when we look at list and string. So if you want to understand how to use the slice operator, you can watch our previous videos where we did videos on the slice operator where we learned list, triples, and all the rest. So I'm just trying to show this here so you can see you can actually remove the OB, so you can have just the 1 and 0s. Now, below, as we can see, binary operators works with 1 and 0, and we have what we call truth tables. Truth tables allows you to know how these 1 and 0s operate with each other when you're using the and, or, so, or not. Now, let's look at the truth table for the and. Now, and 0 and 0 will always give you 0. Now, the truth table, as you can see here, it always returns, while 0 and 1 will always give you 0. Now, it only returns true. The and operator will only returns true if both left and right operand are 1. As you can see here, this is the only situation where the AND operator returns true. Now, you can see the OR operator will return true if either of the operators are 1 or 0. It means if one of the operator is 1, it will return true. If both are 1, it will still return true. But if none of them are 1, or we have all zeros, it returns 0. So in this case, 0, 0, 0 or 0 is 0, but 0 or 1, 1, 1 or 0, 1, 1 or 1, 1. So you can see wherever, if there's a 1 in the left or the right operand, it will return 1. Now we have the exclusive OR. Now the exclusive OR is a bit different from the XOR in that it only returns 1 if one of the operands is 1, not both. So in this case, we return 1, and in this case, we return 1. But because both operands here are 1, exclusive OR is not going to return 1. It's going to return 0, or it's 0, no bit. Now, NOT operator just inverses the bit. If you have 1, not 1 is 0. If you have 0, not 0 is 1. All right, so yeah, assume some numbers. We have 55, which has a binary representation this, and we have B, which has a binary representation this. You can use the bin operator to verify that. Now, here we have and, as you can see, this is what happens behind the scene. Now we have 1 and 0, which is 0. Here we have 0. Here we have 0. Here we have 0, 0, 0. So you see everything here is 0 because it's bit by bit operator, 1 and 0. Now we have OR, as you can see, or wherever you see 1, it returns a 1. So you see 0, 1 here will give you 1, 1, 0 here will give you 1, and so on. Here we have 1, 1, 1. So you see A or B is going to be 127, which is the binary equivalent is 1, 1, 1, 1, as you can see here. Now, XOR is exclusive OR will be the same, because wherever, if you have 1 1 anytime, it's going to return 0, and if you have 0 0, it's going to return 0. But in this case, since we have only one in either, in at least one of the operands, then we have 1 1 1 1 here, 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 1 here. So that's it. So the NOT operator just inverses the bit. So NOT A will give you this, which is 56. Equivalent is 56, and NOT B is this. You see, inverses all the bit. 1 here inverses the bit to, it's supposed to be not, it's supposed to be 1 here, sorry, 1 0 here. NOT B will give you 0 0 1 1 1. Or let's see. All right, so NOT B actually inverts the bits. As you can see here, 0 1, all the bits are inverse, and we have negative 73. Now we can test that with our program. Now we have A, you see we use OB. We have studied this when we look at Python numbers, when we look at this already. So you can declare a number in binary form by preceding it with OB. That's 0 followed by a lowercase b, and here you can see we carry out the operator. Now this is the AND operator in Python. This is the OR, this is the exclusive OR, this is the NOT, which is the tilde sign, and this is the NOT. So as you can see, we have A and B, A and OR B, A XOR B, not A, not B. So this is the equivalent operators in Python, and this is the equivalent binary operator, bitwise operator. Now as you can see, we print C, D, E, F. Here are the values, and here are the binary operators. In your free time, you can check this out and do the calculation. Now here we have more outputs there. As you can see, A or. Now you can't use the bitwise operator with floats. Yeah, I want you to know that you're going to generate an error, and you can use the bin operator also with a float. You can't get the binary number equivalent of a float, of a decimal number. It exists in computer science, but in Python you can't get it. All right, so let's move forward. Now here are the different bitwise operator. We have AND or exclusive, or we have NOT, we have left shift, and we have right shift. We are going to be looking at examples. So below is a brief description of what left shift. Okay, now as you can see, left shift shifts the bits to the left by a given number, and it assigns the empty bits on the right with 0. So as you can see here, these bits have been shifted, all these bits have been shifted, so it's going to have this, and then 0 is filled in behind. Just on your free time, you can verify that so that this video is not going to be too long. Okay, so let's look at it. So this shift by 2 to the left and fills in the empty 2 spots with 0. So as you can see, we are shifting to the left, and this is our result. When we shift to the left by 7, we shift everything out and we have 7. Now here is right shift. Instead, we are shifting to the right and we are filling the empty bits on the left with 0. So as you can see, we shift this to the right one time. This one goes to the 7th position, and we fill in with 0. So in your free time, you can do that. We shift here by 2, fill in with 2 zeros. 3, we fill in with 3 zeros. We shift by 4, filling with 4 zeros, 5, filling with 5 zeros, and so. Now mathematically, when you left shift, you are dividing by 2 raised to the power whatever number you're left shifting by. So for example, left shifting by 1 is the same as saying multiplying by 2 raised to the power 1. That's 4. Yeah, right. Left shifting by 2, 2 raised to the power 2, 2 raised to the power 3. That's 50 times 2, because this is 50. The number here, the left operand, is 50. So left shifting by 4 means 50 times 2 raised to the power 4. So which is 50 times 16. Here we have 50 times 32, 50 times 64. So in mathematics, left shift is also like multiplication, and right shift is like division. Right shift is dividing by 2 raised to the power here 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4. Now the decimal points are discarded. So for example, here we have 6 point something, here we have 3 point something, here we have 1 point something, but as you can see, it's discarded. So I just want you to note that. All right, here we are going to see some more examples. Here we have A, B, C, D. Here is this binary equivalent. Now we can see here, we can say and A and or C, A or E, and not B. As you can see, here is the output. Now we have left shift C, left shift 2, A right shift 4, and here we have the output. All right. This was a very long video on binary operators, and I hope you enjoyed these videos. Trying to keep them under 10 minutes. All right. Have a nice time, and see you in the next video. Thank you.